Hello everyone, this video is the ninth in my series explaining AIME problems. In this video, I'll be talking about coordinate geometry and trigonometry problems and the ways that they can be solved. I encourage you to pause throughout the video and try to solve the problems. Before watching this video, you should know some prerequisites. You should know most of the trigonometric formulas relating sine, cosine, and tangent, etc. You should know the trigonometric formulas for sine, cos, or tan of 2x, and sine, cos, or tan of x over 2, so the double angle and half angle formulas. And you should know basic coordinate geometry, such as slope, x and y coordinates, parabolas, etc. Now, let's start with the problem that involves coordinates. Suppose that a parabola has vertex 1/4, negative 9/8, and equation y equals ax squared plus bx plus c, where a is greater than 0 and a plus b plus c is an integer. The minimum possible value of a can be written in the form p by q, where p and q are relatively prime positive integers. Find p plus q. To solve this, let's write this equation in two different ways. So y is equal to ax squared plus bx plus c. But from the vertex form of a parabola, and we know it has vertex 1/4, negative 9/8, we know that this is a times x minus h squared plus k, where h comma k is the vertex. And plugging in the values and simplifying, we get ax squared minus 1/2 ax plus 1/16 a plus k. Now, we know that these two values have to be integers for x equal to 1. Since when x equal to 1, this simplifies as a plus b plus c. And these should be equal, so it's also the same for x equals 1 here. And for x equals 1, we get that this simplifies to a minus a over 2 plus 1/16 a minus 9/8. And this equals 9 by 16 a minus 9/8. The smallest possible value that we can increase this value by to get an integer is 1/8, since this is at negative 9/8 and the smallest integer greater than that is negative 1. So 9 by 16 a has to equal to 1/8, or a equals 2 by 9. And from this, we get our answer of 2 plus 9, or 11. Let's do another problem that involves coordinates. The graphs y equal to 3x minus h squared plus j and y equal to 2x minus h squared plus k have y-intercepts of 2013 and 2014, respectively, and each graph has two positive x-intercepts. Find h. First, let's set up the equations. We know that 3h squared plus j equals 2013, and 2h squared plus k equal to 2014, since you have to plug in x equal to 0 to get the y-intercepts. Also, let's say this is equation 1 and this is equation 2, and both of these have to equal 0 for the x-intercepts. We get that x for 1 has to equal, for the x-intercepts, h plus or minus square root of negative j over 3, and for 2, x has to equal h plus or minus square root of negative k over 2. So j has to equal negative 3a squared for some integer a, and k has to equal to negative 2b squared for some integer b. Now, let's apply this to these equations. Now, we can plug in j equal to negative 3a squared into 3h squared plus j, and we get that h squared minus a squared equals 671. We can simplify this as h minus a times h plus a, which equals 671. And Testing some factors, we get that 671 is equal to 61 times 11. Now we need to find h, and these two values have to be greater than 0. So we get that h minus a has to equal to 11, and h plus a has to equal to 61. Or h equals 36, and a equals 25. And after checking some values, we see that all of these equations are satisfied. So h equals to 36 is our answer. Now let's do a trig problem. In equilateral triangle ABC, let points D and E trisect BC. Then, sine of DAE can be expressed in the form a root b over c, where a and c are relatively prime positive integers, and b is an integer that is not divisible by the square of any prime. Find a plus b plus c. First, let's draw the equilateral triangle ABC. This is A, this is B, and this is C. And we need to trisect BC with D and E. And the angle that we're looking for, or the sine, is this, the sine of this. Now let's draw the altitude from A to BC. And let's assign BC a random value that'll help. So let's say 6, since we only care about ratios. And if we assign BC as 6, that means that DF is 1. And we're just assigning F randomly. And EF is also 1, or F is the altitude from A to BC. And we know that BF is equal to 3. So AF equals 3 root 3 by the properties of an equilateral triangle. So AD is equal to root 28. And now we can start assigning ratios. Sine DAF is equal to 1 by root 28, or root 7 over 14. But this is not our answer, since we're looking for sine DAE, not DAF. So we need to find sine DAE, which is 2 sine DAF cos DAF by the double angle formula. So we also need cos DAF, which is 3 root 3 over root 28, which equals 3 root 21 over 14. Now, our final answer is 2 times root 7 over 14 times 3 root 21 over 14. And after some calculations and cancellations, we get that this equals 3 root 3 over 14. So our final answer is 3 plus 3 plus 14, or 20. Now let's do a problem that has much more conceptual trig. A disk with radius 1 is externally tangent to a disk with radius 5. Let A be the point where the disks are tangent, C be the center of the smaller disk, and E be the center of the larger disk. While the larger disk remains fixed, the smaller disk is allowed to roll along the outside of the larger disk until the smaller disk has turned through an angle of 360 degrees. That is, if the center of the smaller disk has moved to the point D, and the point on the smaller disk that began at A has now moved to point B, then AC is parallel to BD. Then sine squared BEA is equal to m by n, where m and n are relatively prime positive integers. Find m plus n. So to start, we should just draw a picture. The starting position is here, with the larger circle there and the smaller circle here. This is 5, and this is 1, and this is E, this is A, and this is C. Then later, here's the larger circle and the smaller circle. it has turned through an angle of 2 pi, or 360 degrees. And we know that the tangent is perpendicular to both the radii. So this is just one line. So this is 5, this is 1. And we also know that this distance that the center has traveled is the same as the circumference of the circle, since the center moved exactly the distance that a point on the disk moved. And that would be exactly 2 pi. So it moved 2 pi over 6. So this angle here is 2 pi over 6, since the radius of that circle is 6. And this is pi over 3. Also, this point right at the intersection is A, and this, the point that's facing to the left, is B. And the center of the smaller circle is now D. Now this will look clearer on the next page. Now let's continue where we left off. We want this angle right here. And we know some of these lengths on this picture. Let's call the altitude that I just dropped F. Then dF is equal to 6 times root 3 over 2, which equals 3 root 3. And EF, is equal to 6 over 2, or 3. But we need to subtract 1 from that, since we want B and the altitude from that. And I'll call this point G. So EG equals 2. We want sine of BEA, which equals 3 root 3 over square root of 2 squared plus 3 root 3 squared, which equals 3 root 3 over square root of 31. And this is the same as 3 root 93 over 31. Now if we square this, we get our answer, which is 9 times 93 over 31 squared, or 3 here, 31 there, which is equal to 27 over 31. So our final answer is 27 plus 31, which is 58. Now let's do a problem that involves even more trigonometry. Let triangle ABC be a right triangle with right angle at C. Let D and E be points on AB with D between A and E, such that D and E trisect angle C. If DE over BE equals 8 by 15, then tangent B is equal to m times the square root of P divided by n, where m and n are relatively prime positive integers, and P is a positive integer not divisible by the square of any prime. Find m plus n plus P. First, let's draw a diagram. Here's the right triangle. This is A, this is B, this is C, and C is trisected. And we have that this is D and this is E. And this, the ratio of DE over EB is 8 by 15. Now, let's assign a random variable to BC, or a random number, one that'll make it easy to find the answer. And the easiest one is just 1, since then AC becomes tangent B. Now we know that this is 30 degrees, this is 30 degrees, this is also 30 degrees, and this is 150 minus B, this is B plus 30, this is 120 minus B, and this is B plus 60. Now let's start calculating a lot of values. Let's assign this side as D and this side as E. Then, by the law of sines, we get that E by sine A is equal to tangent B over sine B plus 60. And sine A is just cos B, so E is equal to sine B over sine B plus 60. Now, we also have that EB divided by sine 30 equals 1 by sine B plus 30. It was 150 minus B, but then sine x is always equal to sine 180 minus x, so it simplifies to this. Or EB equal to sine 30 divided by sine B plus 30. Similarly, DE is equal to E sine 30 divided by sine B plus 30. Now, we can substitute E equal to sine B by sine B plus 60. So, DE is equal to sine B times sine 30 over sine B plus 30 times sine B plus 60. And we know that DE by BE is equal to 8 by 15. So 8 by 15 equals sine B over sine B plus 60. And after you calculate this with the trigonometric sum formula, and after a lot of simplification as well, we get that tangent B is equal to 4 root 3 by 11. So our final answer is 18. Thank you for listening. Please like and subscribe, and remember to click the bell icon for more updates.